For the first question on this Regents review, we're looking for the true statement. So in order to tell the relationship between the lines, we do need to solve each one for y and put it into y equals mx plus b form. So for k, my first step is I'm going to subtract 6 from both sides. I'm just going to make a note this is for k. So I have 3y is equal to 2x minus 6 when I subtract the 6. Then I'm going to divide everything by 3 to get the y by itself. So that is 2 over 3x minus 6 over 3, which is just 2. Okay, I'm going to do m now. So to get m, solve for y, I got to move over the 2x and the 6. So I'm going to subtract them both. So I have 3y equals to negative 2x minus 6. And then I just need to divide everything by 3. And when I divide by 3, I have negative 2 over 3x minus 6 over 3 is 2. And then finally, I have to do n. And to get y by itself there, all I have to do is divide both everything by 2. So we have y is equal to 3 over 2x plus 6 over 2 is 3. So I'm going to look at the slopes. And I do see that none of the slopes are exactly the same. So I don't have any parallel lines to each other here. So I can knock out the first one and the second one. Now, answer choice 3 and 4 talk about perpendicular lines. Perpendicular lines need to have opposite reciprocal slopes. That means different signs and the fraction is flipped over. So 3 over 2 and negative 2 over 3 with the negative are opposite reciprocals of each other. So n and m are the ones that are perpendicular. So that's answer choice number 4. For number 2, it's asking us which statement is true. So I have points from line AB, so I can find the slope, and the slope is what I need. So for slope, I'm going to do y2 minus y1 over x2 minus x1, and this is for AB. I'll label that here for AB. So for AB, that is 6 minus 3 over 7 minus 5. And that is, I can't say, over 7 minus 5. So that is 3 over 2. So 3 over 2 is the slope of line AB. I also need the slope of line CD, which I can find using the same slope formula. So 0 minus 4 over 9 minus 6. That's negative 4 over 3. And what I can see here is if I take a look at answer choice 1, these are clearly not parallel. If I take a look at answer choice 2, they're clearly not perpendicular. They're not opposite reciprocals of each other. They are not the same line because that would require them having the same slopes and the same y-intercepts, but they don't even have the same slopes here. So the correct answer is answer choice 4. They intersect. They're not parallel to each other. They don't have the same slopes, but I don't know that they're not perpendicular. They don't have the perpendicular relationship of opposite reciprocal slopes. So they intersect. They just don't intersect to form 90-degree angles. Okay, for number 3, we need to determine parallel, perpendicular, or neither. This one is already solved for y, so I just need to take the other one and solve for y. So first, I'm going to subtract the x from both sides. So it becomes negative when it moves to the other side. Then I'm going to divide everything by 2. Remember, there's an invisible 1 here, so this is negative 1/2 x. 6 over 2 is 3. So now I can take a look at their slopes. So the slope of this line was 2, which we can write as 2 over 1. And this has a slope of negative 1/2. So those are opposite reciprocals of each other. So the correct answer here is perpendicular. And justify your response just means that you have to show work. Okay, now we have some questions on similar triangles. So we have that AB is 9, that BC is 15, that DE is 6, and that EF is 10. And angle B is congruent to angle E. And we need to know which statement is true. Well, I'm just thinking number 3. I'm seeing SAS here, but I gotta just check that they're proportional to each other first. So let me check that out. I'm gonna do corresponding side from this triangle over from big triangle over small triangle, corresponding sides. Got to make sure the corresponding sides are together. I'm going to do 15 over 10, and I'm going to do 9 over 6. And let me see if they have the same scale factor. So 15 over 10 in my calculator, I got 1.5. And for 9 over 6, I got the same thing as well. And the included angles are congruent to each other. So what we do have here is SAS, and that does prove that triangles are similar. If you were confused about 2 or 4, it probably just doesn't have the corresponding parts listed correctly. So I can already see here in number 2, AB and FE don't correspond, so that's not good. And I can see in number 4, let's check out why 4 is wrong. Give me 1 second. This one over here has side from big triangle over side from small triangle, but then they have small over big, so that's not correct setup. It needs to be the same on both sides. And number 1 would be if we prove the triangle's congruent, then the corresponding angles would be congruent by CPCTC. That would be congruence, not similarity. And what we have here is similarity. Okay, number 2, we are told that EF is parallel to AD. And we are also told that EF is parallel to BC. So already I'm seeing that if this is parallel to this and this is parallel to this, then these have to be parallel to each other. So that's something I'm seeing already. That might be important. I'm going to put that in my proof. Just for lack of space here, I'm not going to write the givens, but you definitely need to. So I'm just going to put that here as given, all that stuff. And then I'm going to say that AD must be parallel to BC. And you might be thinking transitive property because, oh, this is parallel to this and this is parallel to this, so these are parallel to each other. But transitive property is specifically for congruence. If this was congruent to this and this was congruent to this, so these are congruent to each other, that would be transitive. But since it's about parallel and not congruent, this we can't just say it's transitive property. We have to say it's transitive property of parallelism. I'm going to abbreviate that, parallelism. Okay. And they also tell us in the givens that AD is congruent to BC. This is super important. Now that we know that these are congruent and they're also parallel, I know that ABCD is a parallelogram. And I know that because if one pair of opposite sides is both parallel and congruent, the quadrilateral is a parallelogram. Okay, so I already drew a lot of the conclusions, but I have no idea where I'm headed. And it's not really a good idea to start putting things in your proof without knowing where you're headed. So let's look at the proof statement. I'm proving a product here. And I know before a product comes a proportion. And proportions come from similar triangles. So I need to prove two triangles similar. Problem is, I don't know which two. So let's take a look at the proof statement. EH is over here. CH is over here. FH is over here. And AH is over here. So now I see clearly what my two triangles are that I'm going to be proving similar to each other. So let me try to get some information in those two triangles. Already one is jumping out to me, the vertical angles. And remember, keep in mind, similar triangle proofs are always AA. So it's super simple. Once we know that we're proving triangle similar, we know that we're on the lookout for congruent angles, like those vertical angles over there. We also know, since we already showed that this whole quadrilateral is a parallelogram, not only is this pair side parallel, but this pair of opposite sides is also parallel. And that makes these angles congruent because they are congruent alternate interior angles. Check out the letter Z. We do have alternate interior angles, which are congruent when lines are parallel. So let's put this into our proof. I'm going to start with the other pair of parallel sides. So I'm going to start with AB is parallel to DC. And I'm going to put here opposite sides of a parallelogram are parallel. And then I'm going to put those congruent alternate interior angles. So angle EA. Oh, I can't see this anymore. I don't know what that is. H, there, that's H. Angle EAH is congruent to angle HCF. And I'm going to put here alternate interior angles. This is not a real abbreviation. I'm just doing it here to save space. Are congruent when parallel lines are cut by a transversal. And now I just need to put in those vertical angles. Angle AHF is congruent to angle FHC because intersecting lines form congruent vertical angles. And now that I have two congruent pairs of angles, I had 1A here and 1A here. Now I can say that triangle AEH is similar to triangle, I should probably name it CFH. And that is due to AA. Now from here, I just need to make a proportion and then I can prove my product. So when I make my proportion, I'm going to put the segments from the proof statement in. And then you just want to double check that when you cross multiply, it actually gives you your proof statement. That's super important. And our reason for a proportion is the same reason every time. Corresponding sides of similar triangles are proportional. And then from here, I just need to put one last step, which is my proof statement. From here, I'm all ready to prove my step number 9. I'm all ready to prove my product. So that was EH times CH. And FHAH. And my reason for that is in a proportion, the product of the means equals the product of the extremes. Remember, it's the same reason every time when you are proving a product. In number 3, we have a flagpole that casts a shadow. So here's my flagpole. Shadows are on the ground, so here's the shadow. And the shadow is 16.60 meters long. Tim is standing 12.5 meters from the base of the flagpole. So let's say that this is 12.45 meters from the base of the flagpole, and this is where Tim is standing. And Tim's shadow meets the end of the flagpole shadow. If Tim is 1.65 meters tall, determine and state the height of the flagpole. So let's close this up over here and let's make 2 triangles. So we do have 2 triangles over here if you take a look. We have the bigger triangle and we have the smaller triangle. They both have right angles and they both share this angle. So they are similar triangles due to AA. So since I have 2 similar triangles, I can make a proportion. I'm going to make a proportion using sides from the big triangle and the corresponding sides from the small triangle. So I'm going to just do big over small equals to big over small. Those don't even look like these. Let me rewrite that. Okay. So I'm going to use the 16.60 from the big triangle. And that's over here. So the corresponding side to it from the small triangle would be here. So that's 16.60 minus 12.45. So 16.60 minus 12.45, that is 4.15. Okay, now I'm going to use the x, which is from the big triangle, and the corresponding side from the small triangle is 1.65 meters. From here, I'm going to cross multiply. 16.6 times 1.65. That is 27.39 is equal to, keep doing that, 4.15x. Let me divide by 4.15. And I got 6.6. Oh, I put 6. Wait, did I put 16.6? Yeah, 16.6 times 1.65. And then, okay, I did it right. Okay, so 16.6 meters. I'm going to put that here. 6.6 meters is the height of the flagpole. Okay, moving on. Now we have some practice questions on both of the previous topics. So we need the equation of a line that passes through 6,1 and is parallel to MN. So here's the point 6,1. So I'm going to get the slope of this line first. And since I have a graph, I'm just going to use rise over run, but you very well could just use slope formula if you don't like that. It's a decreasing line. So I am going to have a negative slope. And the rise is 1, 2, 3, 4, 5, 6. And the run is 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's a slope of negative 6 over 9, which reduces to negative 2 over 3. So we need parallel, so that's same slope. So I know it's got to be answer choice 1 or 2. Now, I'm just going to use point slope form to write the equation of the line parallel to this one that passes through this point. Point slope form is y minus y1 equals to m x minus x1. And I'm just going to pick one of the points, M or N. It doesn't matter. They're both on the line that it needs to be parallel. Actually, no, I have to use the point 1. That's the point it has to pass through. I'm losing my mind here. That's the point we're going to be using. So we have y minus 1. That's the y coordinate from the point, is equal to our slope. X minus x1, that's 6. The answer choices are solve for y, so I'm just going to solve for y here. First, I'm going to distribute these out. Negative 2/3 x plus 4. And then I'm going to add 1 to both sides. So that's y equals to negative 2/3 x plus 5. That's answer choice number 1. There's other ways that you could have done it, but that's just the way I did it. As long as you got the same answer and you know how you did it, then you're all good. This one, I'm going to first start off by solving for y. So we have negative y is equal to negative 2x plus 7. I just subtracted 2x from both sides. Now I'm just going to divide everything by negative 1 to get y by itself. So that just flips all of the signs, and that's our equation of the line. Perpendicular is opposite reciprocal slopes. So the opposite reciprocal slope of 2 over 1 is going to be negative 1/2. So this is going to be the slope I'm using. So I don't have any other information here. So I just need to look for the slope. And there it is. We need parallel to this line. So first I'm going to solve for y. So we have 3y is equal to 2x minus 4. Divide everything by 3. 2/3 x minus 4 over 3. So our slope is 2/3. Parallel, so same slope as this one. And this is the point it needs to pass through. So I'm going to use point slope form once again. And I'm going to plug in the point that we need and the slope that we have. And our answer choices are already in point slope form, so that makes it super easy for us. The correct answer is answer choice 2. I'm going to solve our equation of the line for y. So first I'm going to subtract 3x from both sides. And then I'm going to divide everything by -5. So that's going to change this to positive, and that's going to make this negative. So our slope is 3/5. So I need the perpendicular one. So that's the opposite reciprocal, which is -5/3. And that's answer choice number 4. Here we need perpendicular to this line. So I'm going to start off by solving for y. So we have -4y is equal to -5x plus 10. Divide everything by -4. And we have 5/4x minus 10/4. So our slope is 5/4. We need perpendicular, so the perpendicular slope is going to be -4/5. And now I'm going to write my equation of the line using point slope form. And I'm going to plug in the point that we have to work with and the slope that we found. And I'm going to just leave my answer like this. You can solve for y, but it's a short answer question, so why do it if you don't have to? That is a perfectly valid equation of the line. It's just in point slope form and not in y mx plus b form. We have a couple of more questions on similar triangles. So this one is actually from the test that we just had, test number 3. It's the extra credit question. I'm not going to do this one on this video because I did it on the test video. It's the extra credit question, so definitely check it out on my test video. I'm going to go down this way this time. So over here, I have AC is 7.2 and CE is 2.4. And we need which one is not sufficient to prove that the two triangles are similar. Keep in mind, we already have these vertical angles. For number 1, if we're told that these are parallel, we have alternate interior angles. So this would be enough. That would be AA. So goodbye, answer choice 1. For answer choice 2, 2.7 and 8.1. Let's see if these are proportional. So 8.1 divided by 2.7, I got 3. And 7.2 divided by 2.4, I also got 3. So this is good. They will have the same scale factor. That means, wait, let me put that back. So that's an S, that's an S. Oh, but the A is not in between the two S's. So this is not a valid method because we don't know anything about this. So it's not SSS. And in order to be SAS, the angle would need to be in between the two sides. That almost got me there because they are proportional. So this is the right one. If we take a look at the other answer choices, just to be sure, CD is 3.6 and BC is 10.8. This is SAS because the angles in between the two proportional sides, and if you check, they should be proportional. And for 4, they also give you measurements of A, B, and DE. So if you try those out, you should have that they're all proportional, and that would be SSS. Here we have a rectangular flat screen TV, and the ratio of the width to the height is 16 to 9. So I'm just going to represent it with x's. The length of the diagonal of the screen is the screen size. Determine and state to the nearest inch. So we're looking for this over here. And we know that the height is 20.6. Okay. So 16 to 9 is the ratio here. And we know that the height, the 9 part, is 20.6. So if we set this up as a ratio, as a fraction, 16 over 9 is what if 20.6 is the 9 part? So I'm going to cross multiply here. 16 times 20, oops, I typed the wrong thing into my calculator. 16 times 20.6 and that is 329.6 equals to 9x. So I'm going to divide by 9 on both sides. And on my calculator, that's approximately 36.6. So here in this situation, we know that the height, the 9 part, is approximately 36.6. Oh, sorry, I mislabeled over here. I'm losing my mind today. So we were given that the height was 20.6. And using our proportion here, we figured out that based on the ratio, if the height is 20.6, if the 9 part's 20.6, then the 16 part has to be about 36.6. And we have a rectangle here, so we have right triangle. So we can just use Pythagorean theorem. We can do 20.6 squared plus 36.6 squared equals to the hypotenuse squared. And I'm going to do this in my calculator. 20.6 squared plus 36.6 squared. And I got 173.92. And then we can just take the square root of that. And it does say to the nearest inch. So I got approximately 42 inches. Okay, I'm just going to erase this over here so I have room for the next problem. Okay. We need the length of HI. So I'm going to set up a proportion. We do have similar triangles. These are parallel. So we do have the congruent alternate interior angles, and we do have the vertical angles. So they're similar by AA. So I can make a proportion. So I'm going to do small over big, just make sure they correspond, equals to small over big. The numbers here are just annoying. Let me cross multiply. So 15 times 6.5, sorry, times 6.1. I almost typed 15 into my calculator. So I got 30.1x. Now that's going to be 5 times 6.5. And that is 32.5. Now I'm going to multiply the other way. 12 times 1.4 is 16.8x. And then I also have the 12 times 3, which is plus 36. So let's get this together here. I'm going to add 32.5 to both sides. So this is 30.1x is equal to 16.8x. 36 plus 32.5 is 68.5. Then I'm going to add 8x to both sides. So 30.1 plus, oh, that's 16.8. Ooh, I can't even read my own handwriting anymore. I really should have used more space for this. Let me rewrite it over here next. So far, just from this step over here, we have 30.1x equals to 16.8x plus 68.5. Okay, so I'm going to subtract 16.8. That's a point. I'm going to subtract 16.8 from both sides. So 30.1 minus 16.8 is 13.3. So here I have 13.3x is equal to 68.5. I'm going to divide by 13.3. And I got 1 for the length of x, but that's not the answer. We need the length of HI, so don't pick x. We have to plug in. We're plugging in over here. So that's 6.1 minus 6.5 Okay, so I messed up my numbers here. So I'm going to do this again, and this time I'm going to try to write bigger and not mess up my calculations. So I'm going to make the proportion one more time and cross multiply. So I'm going to do the same way I had it before. I'm going to do 5 over 12 equals to 1.4x plus 3. Let me write that better because I'm going to get confused again. So hard to write on the computer. Over 6.1x minus 6.5. Now let me cross multiply this. Okay, so 5 times 6.1, and that is 30.5x. And then I have 5 times 6.5, and that is minus 32.5. Now the other way over here, we have 12 times 1.4, and that's 16.8x. And then 12 times 3 is 36. So I'm going to add 32.5, and I got 68.5. So let me rewrite this. 30.5x equals to 16.8x plus 68.5. Now I'm going to subtract 16.8. So that is 30.5 minus 16.8. And that is 13.7x equals to 68.5. Now I'm going to divide by 13.7. And I got x is 5. But that's not the answer because we have to plug in, but now it's making more sense. So we have 6.1 times 5 minus 6.5. And the answer is 24. Okay. Over here, the ratio of similarity is 1 to 2. BOY is at the top, so I'm going to put x plus 3 at the top. And then GR is from the second one, so I'm going to put 3x minus 1. So that's 3x minus 1 equals to 2x plus 6. Subtract 2x, add 1. X is equal to 7. And then we need to plug in to find what we're looking for. 7, 14, 21 minus 1 is 20. Okay. Here we have a proof. We're just proving the triangle similar. It's going to be a simple AA. We have a parallelogram. Opposite sides are parallel. So you know we have those congruent alternate interior angles, and we also have the vertical angles. Super easy. Gonna write this up super quickly, not putting the givens just for lack of space and lack of time, but you do need to put them, so please make sure that you do. Then I can say that DA is parallel to CB. My reason for that is opposite sides of a parallelogram are parallel. And then I can say angle EDF is congruent to angle FBG. And our reason for that is alternate interior angles are congruent when parallel lines are cut by a transversal. That is not a real abbreviation for alternate interior angles. I just want to save some space here. And then angle DFE is congruent to angle GFB. And our reason for that is intersecting lines form congruent vertical angles, not a real abbreviation, just saving some time and space. And then we can say that triangle DEF is similar to triangle BGF, BGF, and that is due to AA.